Good afternoon, everyone. You are welcome to my YouTube channel, and this is the second video that I'll be releasing. A student asked me to explain this particular topic for her in chemistry, and the topic is redox reaction, because we have some topics in physics and chemistry that some students they find it difficult solving. Now, this is a redox reaction. Now, if you want to solve redox reaction, two things are involved. Number one, you must check the question if the question is an acidic medium or basic medium. Now, we're talking about acidic medium. And basic medium. In acidic medium, we make use of hydrogen ion and H2O. That is for acidic medium. But for basic medium, we have OH minus and H2O. Now, how do you know if a question is acidic medium or basic medium? As it is, it's going to be indicated in the question if you are dealing with acidic medium or basic medium. Looking at this question now, it is acidic medium. That means what you need to deal with now is the hydrogen ion and water. Now, how do we do that? The first thing that you need to determine here in this redox reaction is that number one, you're supposed to know the one that undergo oxidation reaction and reduction reaction. And don't forget that in oxidation reaction and reduction reaction, we have different definitions for oxidation reaction and redox reaction. We can define oxidation reaction in terms of oxygen, you can define it in terms of hydrogen, you can define it in terms of electronegativity, you can define it in terms of electropositivity, and at the same time you can define it in terms of electrotransfer. Now, we need to reduce this redox reaction to half equation. Now, how do we do that? We take MnO2 going to Mn2 plus, and we have Fe2 plus to Fe3 plus. Now, which one undergo oxidation reaction, which one undergo reduction reaction? We can use this one in terms of electrotransfer. Now, let's check manganese. Manganese from the reactant side. Let's calculate for the oxidation number of manganese here. We have MnO2 equal to 0. Anytime we are looking for oxidation state of a particular element in a compound, if the charge is not indicated now, you equate that compound to 0. Now, this one is what you are looking for, which is the oxidation state of manganese. You represent it with unknown letter. Plus, what is the charge on oxygen? That is the first thing that you're supposed to know as a chemistry student, the charge on each element. And the charge on oxygen is -2 times what? Times 2 will give you 0. And that will be x. Minus x plus will give you minus, will give you 4 equals 0. X equals to 4. That means manganese, the oxidation state of manganese at the reactant side is +4. And the oxidation state of manganese in the reductant side is +2. Now, to show that from +4 to +2 is what? There is loss of what? Loss of electron. Which shows that this manganese undergo reduction reaction, and this is oxidation reaction. Now, because this one is moving from +2 to +3. Now let's go to balancing of redox reaction in details. Now let's go for the oxidation reaction, which is Fe2 plus to Fe3 plus. Now if you want to balance it, you check oxygen, you take hydrogen. Looking at this half equation reaction now, we now have oxygen, no hydrogen. That means you need to balance it ionically with their charge. Now, ion is moving from +2 to +3. That is what? gain of what? Of electron, because it's moving from +2 to what? To +3. Now, for us to balance this equation we need 1 electron to balance this equation. Now that 1 electron, now don't forget that electron is carrying negative. That means Fe2 plus will be Fe3 plus electron. Alright? We've checked hydrogen. Hydrogen is not in this equation. We've checked oxygen is not there. That means we need to balance it ironically. Now let's check if this equation is balanced. Oxidation state of iron here is +2. Oxidation of iron here is +3. +3 minus 1 will give you what? Will give you +2. We can call this one equation 1. Now we are done with the oxidation reaction. Now let's go to reduction reaction, which is our what? MnO2 to Mn2 plus. Are we there? Now, checking this equation now, you see that there is presence of oxygen here. Now, we need to balance this oxygen. Now, if you want to balance this oxygen, you look for the side of the equation that is deficient of what? Of oxygen. Now, looking at the product side now, there is absence of oxygen here, no oxygen there. Now, we now add the number of oxygen that we have here to the what? To the product side. And this one will be, you first add water to this side, that is H2O. And how many molecules of oxygen do we have here? We have 2 molecules. And that will be the number of mole of water that we are going to add at the product side, which is what? 2H2O. Looking at oxygen, the oxygen is balanced. We have 2 oxygen here, we have 2 oxygen here, we have 2 oxygen here. But mind you, hydrogen is what is, we have hydrogen at the product side here now. That means we need to balance the reactant side with hydrogen as well. Now from there, we have MnO2 and we have Mn2 plus 2H2O. In order for us to balance hydrogen now, checking the product side, we have 4 mole of hydrogen there. Now for us to balance this, we had the 4 mole of hydrogen again to this side, which is plus 4 hydrogen plus. Checking this equation now, we balance this equation with oxygen, hydrogen. Now the next thing that you need to check is your charge, which is electronic charge. Now how do we do that? Let's check. Now we have the plus 4 here, we have the plus 2 here. Alright? In order for us to balance this equation now, we need 2 electrons to balance this equation. We need 2 electrons. That 2 electrons, we are adding it to the what? To the reactant side, which is MnO2 plus 4H plus 2 electron to give us MnO2 plus 2H2O. Now let's check if this equation is balanced. The state of this compound is 0. This is plus 4. This is minus 2. This is plus 2. This is 0. Plus 4 minus 2 will give you 2 electrons at the reactant side and 2 electrons at the product side. Now let's balance it simultaneously. This is equation 2. Now let's put the 2 equations together, which is Fe2 plus Fe3 plus electron, and we have MnO2 plus 4 hydrogen ion plus 2 electron, and that will give you Mn2 plus 2H2O. Now you want to balance this equation simultaneously. Now looking at this electron, you will see that we have 2 electrons here, we have 1 electron here. In order for us to balance it now, we multiply this one by 2, multiply this one by 1. From there, we now have, if we multiply this one by 2, it's going to affect the 2 sides of the equation, which is 2 Fe2 plus will give you 2 Fe3 plus 2 electron. Now, checkmate, we have this one will cancel out this. We now left with what? With the reactant side and the product side. We put the reactant side of the 2 equations together. We put the product side together. This one will now give you 2Fe2 plus Mn2 O2 plus 4 hydrogen ion, and this one will give you 2 Fe3 plus Mn2 plus 2H2O. Now let's check if this equation is balanced ionically. We have 2 plus 2 times 2 will give you plus 4 here, and the charge of manganese of this compound now in what's it called, in the neutral state, which is ground state, which is 0, and this one is plus 1 times 4 will give you plus 4, and this one is plus 3 times 2 will give you plus 6, and the charge of this one is plus 2, and this one is 0. At the product side now, the number of electrons that we have at the product side is 6 plus 2, which is 8 electrons. Let's check this place. 4 plus 4 will give us what? 8 electrons. For us to know that this equation is what? Is balanced ionically. Now, the way they normally ask this question in WAHEC and JAM, you can be given this equation as it is. They will now remove this number of mole there, and it's going to be represented by what? By X, Y, and Z. Looking at this, let's use this one as an example. You can be given this. This is how they ask questions on redox reaction. The question will now say that find X, Y, and Z respectively, and the options will be given. Now, checking it, you will see that X is 2, Y is 4, and Z is what? Is also 2. That is redox reaction. We are going to stop here for today. Next class, we look at questions on redox reaction, basically on basic medium. We use that word on the reaction on basic medium. Now, for this, if you have any question related to this redox reaction, you can type your questions below, and don't forget to share, like, and comment.